Hey everyone, and welcome to the KansasFest session on A2osX. I am Patrick Klepfer, and we'll be providing today's overview and demo, and time permitting, we'll answer any questions we have at the end. Over the next 20 or 25 minutes or so, I hope to give you a basic understanding of A2osX and how it is built, what it can be used for, and how you can add to it yourselves. What is A2osX? Is it a program launcher like BitsyBy? A command shell or programming environment like you find in Aztec or Cayenne? Or is it an operating system? When I was writing the documentation, I had trouble calling it an OS because Protos was the OS and A2osX ran on top of it. So I started describing it as an operating environment like TopView or DeskView for PC. Truth be told, is more comparable to Windows, which originally ran on top of MS-DOS, but which is today a full OS. The main force behind this project is Remy Guibert, who got us started on the 6502 at 12 and later on the Apple II. Back in 2015, he discovered a box of his old floppies containing the SC MASM source, obtained an Apple to recap, where he found himself back in the 8-bit world coding with a vengeance. While working on several projects such as scripting, a TCP/IP stack, better graphical libraries, he got fed up rebooting to another disk just to switch to another task. Why not build a unified environment where copying files, editing, networking does not require rebooting and switching programs? Hence, A2osX was born. Let's take a quick and high-level look at A2osX. How is it constructed? What it does? And what it provides to both the user and hopefully a growing base of developers. As I mentioned earlier, A2osX loads on top of Protos and is in fact tested with multiple versions on a regular basis. At the core, there's the kernel, which provides the process scheduler and a set of APIs for tasks such as I/O, terminal screen handling, memory stack management. The system can load additional libraries, like a compression library for packing files, and drivers for hardware devices. What we call bins, well, because they are stored in the bin directory, use the libraries and drivers to form complete services, servers, and apps or utilities. A bin can be as simple as WC or word count that displays the character, word, and line counts for a file, or as complex as edit, a complete full-screen large file text and source file editor. An important point here, code is only loaded once. So yes, the libraries can be shared by multiple programs, and in addition, if the same bin was running more than once, say you were editing two different files at the same time, the code for edit would only be in the system one time. Let's walk through the boot process, which will show not only what is going on under the covers, but also more fully show how A2osX is becoming a complete operating system for your venerable Apple II. When you start A2osX, the system file, the first thing it does is check to see if there's a logo, and if so, it displays it. And now that the marketing feature is out of the way, we'll get to the technical parts. The real thing it does is check that your system has at least a 6502 and 128K of RAM, which are the minimum requirements. If so, it disconnects the RAM drive and so that we can use both banks of memory for A2osX. Next, it will look in the sys directory and automatically load any file starting with KM. These are like patches to underlying Protos that add functionality that A2osX can use. One is KM NSC for the no-sock clock. This is in essence exactly what NSC clock.system does. There's also one to set up a RAM disk if you have a RAMWorks card, and if you have ADT Pro set up to share drives, there's a KM VS drive that allows you to connect two virtual drives over the first SSC in the system. We plan to add some other KMs, like supporting AppleTalk in the future. Once these modules have been loaded, the Protos quick code routines are updated and told that the next process to load is syskernel, and A2os system exits. This loads the kernel. The purpose of the new QC system is so that in the future we can allow a user to run another Protos system command that will get loaded into QC, and A2osX will do a restart, causing it to exit and your program to run. When your program quits, the QC system will then reload the kernel all over again. The kernel will create its memory banks for different functions and set up its process scheduler, and loads via NoHup the first process, initd. Initd then creates the console device for output of system messages and executes the tasks found in etc init, each of which is treated as a NoHup initiated system process, meaning they're not connected to a user, and the console will become their output device. Out of the box, etc init is set to create the getty and with it login processes for the virtual terminal set up on your Apple II. The default is 2, but this can be changed to up to 8. There is an impact to memory for each virtual terminal. In addition, the example init file has several commented out lines that you can edit to add support for real terminals, which are connected via super serial cards, or to load drivers for a network card, initialize the network service, and then even automatically start up servers such as the provided web server or telnet D server. These server processes are smart enough to wait for the network to fully load and fully initialize before trying to provide the services themselves. This helps if you are using DHCP and have delays in obtaining your address lease. Right now, the network support is only for TCP networks with either static or dynamic IP addresses. We do plan to add support for AppleTalk or EtherTalk networking in the future. This is why you see in the diagram that init is loading the generic network D, which itself looks in etc network D to see what protocols to load. In the case of TCP, it then looks at TCP/IP-conf for settings for your network. This makes A2osX really customizable to each individual's situation. Once Getty is loaded and starts the login process on that particular device, you will see the standard A2osX welcome banner, and you can log in with a valid user ID and password, which are handled by the kernel. When you start A2osX for the first time, there are no users created yet, so in that case, login will automatically log you in as the root user. When a user logs in, login will load the shell, or bin.sh, and execute the script profile found in the user's home directory. You can see here in the little screen insert the process is running from a booted system, which include the ps command itself being executed. For those of you interested, here is a cursory overview of the A2osX memory map. As you can see, it makes extensive use of both main and auxiliary memory. In fact, much of A2osX itself is loaded in aux opposite Protos. This helps provide the largest possible memory pool for user applications, or what we call bins. I have shaded those areas that are used to store code in blue, while those used to store data in purple. A couple of notes here. One, the space for DHGR, or double high resolution graphics, is only set aside for that use if you have loaded the DHGR driver. If not, then that space is part of their respective memory pools. Second, let's talk about those frame buffers and the aux pool. As I said earlier, you're allowed to define from 1 to 8 virtual terminals for the Apple console. It has to keep a buffer for each of these screens that gets switched back and forth to the actual physical screen. These all go into aux. The difference between 2 virtual terminals and 4, for instance, is less than 1K on main memory and 5K on aux. In addition, aux is used to store things like the user database, which we call PWD, any lists created by the slist API, your shells environments, and pipes. In A2osX, lists are used for a lot of things, like your shell history. Or in shell scripts, functions are defined as a list of statements. These get stored in aux. In this way, you can actually write larger script programs that don't take up main memory. More on that later. One of the nice things about A2osX is its set of loadable drivers to support various devices such as network cards, super serial cards, mice, graphics, and even in the future, mocking boards. These drivers can be loaded automatically at startup, as we discussed, or manually from the command line, or in scripts as needed. As a bonus, drivers are loaded on auxiliary memory, so they don't take memory away from the apps that you create. Likely the most interesting part of the drivers for many of you is that there is a set for network cards, the LanceGS, the original Ethernet, and the Ethernet 2, that talk to those specific bits of hardware, but present the same interface to the network libraries. This allows programs like Telnet and Ping and HTTP GET to all be hardware independent, and in fact allows you to run the same programs and scripts on real 2Es with a U2 card or on an Apple Win emulating the original Ethernet. There's also a driver for the SSC that can be loaded for more than one card. When you load the driver, it creates a new device based on the slot it found your SSC in, such as DevCom2 if it's in slot 2. You can then use that device for Getty, meaning you can attach a physical terminal to it, for Term, which is a VT100 terminal emulator, so that if you're connected to a Linux box on that port, you can telnet it. It's like Telnet, but over SSC. Lastly, you can direct output of commands like cat or a directory listing to the device if there's a printer there. As an aside, we'd really love to have someone take the source for the SSC driver and make one for the SCC of the 2GS. Likewise, anyone familiar with the mocking board could really help complete that driver and make a library for other programs, such as games, to play music. This is the part where I like to say where the power is, but also the burden of developing with A2osX comes from. Very much not unlike Windows and .NET. You sort of have to use the tools. A2osX provides a bunch of HPIs and some libraries that do the heavy lifting for you. For instance, the whole screen or terminal management system is written around providing a VT100 interface to or from the user. This is why in scripts you can send VT100 codes for clearing the screen or positioning the cursor. Basically, the kernel provides you with a VT100 screen you talk to, and you don't care if it's an actual Apple II video card, keyboard, a terminal connected via a super serial card, or a remote user coming in via Telnet. Now take a look at the Telnet client. Wait for it. It is 1,000 bytes long. How? Because it's largely a simple loop looking for keystrokes and passing them on and taking packets coming in and shoving them at the display API. If you think about it, the network libraries are doing all the sending and receiving of packets and the underlying acts and such that the protocols need. And as for display, Telnet just needs the foreign host, and I'm a VT100 terminal, passes any data to the display APIs. All that complicated code you think would be in the client is handled by the system. One time, I don't know, about a month ago, I asked Remy, could we have a terminal app so I could have two apples sitting side by side, and much like Telnet, could connect one to the other as a second user, but using SSCs. He wrote the terminal program in one day using those existing APIs and the existing driver. That program term is only 387 bytes long. There are APIs and libraries in A2osX for file I/O, device I/O, block device access, network access, handling TCP streams, and all the underlying sins and acts for compression and decompression, and even an MD5 library. I talk about APIs and libraries. They're similar, but one difference. Some APIs are inherent in the system. They're in the kernel, like file device I/O functions, such as printf. There are others, like compression and networking. They're put in external libraries. These libraries, if used in an app, get loaded, and if not already loaded, they get unloaded when the last app is using them, freeing the memory. All this comes at a price. You have to use these libraries for your programs, though. They're made re-entrant and are blocking as needed. For instance, if there's an API to create a file and write data to it, that library makes sure it completes the operation, before another function might come along to write to a different file in the system. But the benefits are great. Besides being done, as I said, they're all reentrant, all inherit preemptiveness, and support piping. Down the road, we hope to add more libraries, such as the one for GUI user interface. Now I'm going to walk briefly through what is included with A2osX. System programs are in the SBIN directory, and they include what we call system processes, those not usually associated with the user. Most of these were mentioned during boot, but I'd like to call out the last two again, telnetd and httpd. These are both full servers that support multiple connections. In the case of telnetd, this server waits for incoming connections, and when one comes in, creates a virtual device for that connection and starts a getting process, which starts logon, etc. If another user connects at the same time, another device will be created, and so forth. Okay, a lot is made of the networking capabilities, so it's worth a brief mention of all the tools that are available. ipconfig can be used to see your current connection information, and ARP, DNS info, and netstat will let you see the current session info, routing that's going on, and you even have the venerable ping to test that you can reach a site. In the 093 release, you have a telnet client and an HTTP GET utility, which is seemingly for retrieving HTML web pages, but it's actually a sneaky little utility that can be used in the same way as if TTT65, in that you can use it with webhooks to tweet or post messages to Slack. Actually, we could use some help here with writing some instructions and setting up scripts to automate that for other folks. Of course, no OS would be complete without the obligatory set of utilities. It has ones for copying, moving, renaming files. There's also ls for listing subdirectories, aka cat or catalog. Not to be confused with cat, which dumps the contents of a file to the screen or to another device. Some might find handy the cut, grep, more, wc, or word count, and cmp or compare utilities, which can be used to look through one or more files and process the text in your files. Later we'll talk about the shell and how you can combine multiple of these to produce sweet results. Some other things worth mentioning. Most I lop into the set I call admin tools. kconfig allows you to configure certain parameters of A2osX, such as how many virtual terminals, to use preemptive multitasking versus cooperative multitasking. For this, you need an appropriate tick device, what we call tick device or interrupt device, such as a mouse card or a thunderclock. You can also use kconfig to disable a particular slot, so that when you're installing drivers, it won't trip a ROM of an unknown card type while it's looking for, say, a network card or an SSC. There's also the ps command and kill commands for listing running processes and killing ones. This can be useful tools for developers. Speaking of which, the set of development tools we have so far include a full-screen long file editor, an assembler that supports macros and include files, and utilities to track and dump memory usage. These are also handy utilities like PS just mentioned to be used in virtual terminals where you can be running a process in one and switch to another to look at the system, memory, network status to see what's going on with the app you just wrote. For those interested, the main difference between SCASM and our assembler is that SCASM is static, where ours is table-driven, so you can actually add additional CPU types to the assembler by just providing an appropriate table. Both assemblers share the same dialect with dot directives, includes, macros. A side benefit of this is they're both source code compatible. For us, if say we had an error assembling the kernel itself, we can actually drop in a patch in the SCASM assembler and test it with less reboots, cycles, fixes, etc. One thing that hasn't been mentioned yet, and I should, this is a full assembler. You can make standard Protos system files, not just A2osX bins. Speaking of bins, FY, the two largest outside the kernel, which is about 26K, are edit and assembler. The third largest, I'm going to talk about now. And that's the shell. This is the part that most users will probably think A2osX is, because it's what you see. But that's like thinking bash equals Linux. It's the part you interact with. The shell in A2osX, or binsh, is modeled after bash and has many of its features, including things like a history, though not saved, it's only for the current session, that you can scroll through, environment variables, scripts, and scripts that can call other scripts, full parameter or argument passing. The A2S test system is actually a series of about 100K worth of scripts that call each other and keep track of error counts, test runs, outputting all of the results to a single file. You can even do complex things inside of scripts or at a command line, like do a for loop of instructions based on the result of a command itself. Part of the make system to build release media uses a for var in a file and then copies the vars to a destination. This way, when I want to add new modules to the media, I just update the file containing the list of files to copy and not have to touch the script. If you ask, why not just copy all? Two reasons. One, I can make sure not to pick up any not ready for prime time bins. And two, I can pre-sort my copy lists so the files end up alphabetized in the resulting media. Hello, Bobby! Lastly, let me just reiterate that the shell and A2osX fully supports piping and redirection. I mentioned earlier you can cat or dump a file to a device such as a printer. But also, if you have a script that normally outputs to the screen, you can simply run the script and add a redirect to a file, and it will handle it for you. Protos. We all love Protos. It has pro right in its name, so you know it's good. Today there are some new variants, a couple included with A2osX. First is Protos 203TC, which is simply 203 with 8 bytes patched for the current set of years. The other is a completely refactored version of Protos that we call FX. It was started initially to improve the interrupt handler in Protos to better support preemptive switching in the process scheduler. Since A2osX requires an enhanced 2E, a lot of the legacy code could be removed, making room for new features such as lowercase support, ACLs, support for drive remapping, additional clock support, and now we can actually edit and assemble Protos in A2osX, so we're close to a full system that can build itself. Okay, now it's time for some demos. Okay, I'm going to speed through some things pretty quick just to show you A2osX. Like getting a directory listing, you can even get a list of all the volumes that are online, and the -L normally would give you what catalog does, but for volumes it shows you the total disk space and what device it's on. We can also switch. I've talked about virtual terminals a couple times. We can switch to another one, log in again, log in as a different user. We can switch to the console, and you can see the output of the boot up messages that have come up, and when I started networking that my IP address was leased. And in fact, since we're talking about networking, I'm going to connect to one of our favorite BBS's, A80s. You can see I have a simple little script here I've written so I don't have to type all that out every time. So just type demo 1, it'll load telnet and connect automatically for me. And you can see A80s is up, and in fact I have another host I can connect to, which is actually an Apple IIe sitting next to me running A2osX, and you can see it's giving me that login screen for that system, and I can log in. And to show you that, if I switch, here's a split screen with the output of the Apple IIe on the left, and my machine, AppleWin, is up here on the top right. And in fact, if I type who, you can see that the root user is logged into that virtual terminal 2 on the physical Apple, and I'm logged in on this TTY57 that was made up by the telnet server. Now if you notice, in the bottom right hand corner of the screen is another login. That's actually PuTTY running on my Windows system. So now I've logged in 3 times to the same Apple IIe, and it's handling the output for it's handling those users all at the same time. And you can actually see the cursor blinking and everything. I'm going to log out of that and switch back. I'm back in AppleWin, and we can log out. We're still connected to the Apple IIe, and we can simply hit the exit key from Telnet, and we're back on our local system. There are, as I mentioned earlier, went through all of the various commands that are available. There's actually some new ones we're working on, such as a IRC client, where as you see here, it's connecting to an IRC host, and we've actually got a A2osX channel that we've established. So once we push this out to more people, I'm going to get out of that, push this out to more people, we hope to have a chat channel that people can, from A2osX, be able to talk to each other. The last thing I want to show you is, oh, that's me, sorry. Go back to, this is the TUI we talked about that was running the Telnet session, and if I switch over to its console, you see the output of it, and you can see where Telnet D was processing incoming connections. On the right, you see standard Chrome browser, and if I click the right window instead of the presentation window, 92.168.0.47, you can see in the web browser on the right, it's loaded a web page that is being served up by that Apple IIe, and you can actually see the messages on the left hand side. And as again, I got to click the right place. As I click other pages, you can see on the left the Apple responding and serving them. This is running at the same time as the Telnet server, and again, if I switch back to the console, to a virtual terminal, I can do any work of my own. And that's all happening concurrently. Okay, I'll stop now, and if there's any time, answer any questions you have.